Welcome to another fantastic day of notes for algebraic reasoning. Today we're going to talk about perfect square trinomials and difference of two squares. All right, so first of all, let's factor these two trinomials. First one, x squared plus 10x plus 25. So we can go x, we know it's going to be plus plus, and we need the factors of 25, which add up to give us 10. And that is just 5 and 5. 5 times 5 is 25. All right, what if we do the second one? Remember, we're going to do our no fuss method. We do 4x, it's plus and plus, so this one's going to be plus and plus. All right, so 4 times 9 is 36, and we need the factors of 36 that add up to 12. So 1 and 36. 2 and 18, 3 and 12, 4 and 9, 6 and 6. There it is, it's 6 times 6. So 4x plus 6, and now we look at our common factors, our GCF. So we're going to divide both of these by 2, and that gives me 2x plus 3, 2x plus 3. What do you notice? Well, I noticed that both binomials repeat. All right. We might say that it's a binomial squared. We could say this one is equal to x plus 5 squared, and this one is equal to 2x plus 3 squared. So it's a binomial that's squared, and that's why it's called a perfect square trinomial. So a perfect square trinomial is of the form a squared x squared plus 2abx plus b squared, and can be factored as ax plus b squared. All right? So in other words, we'll have a squared number in front of our x squared. It's a perfect square. It starts and ends with a perfect square, and the coefficient in the middle is 2 times each of those. All right? So let's practice on some. First one, this one's pretty easy. The square root of 16 is equal to 4, and 4 times 2 equals 8. So this one is, and because it has a minus sign here, we know that both of them are minuses. So this is x minus 4 squared. Here, I know the square root of this one is going to be 3x. The square root of this one is 5. All right? And then 2 times 3 times 5 equals 15 times 2, which is 30. Obviously, there's a typo here. This should be 30x. So make sure you make that change on your notes. So this is 3x plus 5 squared. All right? And it's plus. And for our last one, the square root of 36x squared is 6x. The square root of 49 is 7. 2 times 6 times 7 is 42 times 2, which is 84. So this one is, in fact, 6x minus 7 squared. All right, so those are perfect square trinomials. All right, now let's talk about something else. It's called a difference of two squares. So if we encounter a binomial that's of the form a squared x squared minus b squared, it can be factored as ax minus b and ax plus b. It's just that simple. So let's look at our first example here, x squared minus 16. There's no coefficient, so they're both perfect squares. This one can be factored as x plus 4, x minus 4. We take the square root of the last one. And let's FOIL this one just to verify. X times x is x squared. The outside term is minus 4x. The inside term is plus 4x. And then the last term is minus 4 times 4, so minus 16. These two cancel, and we're left with x squared minus 16, which is what we began with. All right. Next up, x squared minus 81, x plus 9, x minus 9. As easy as can be, right? And for our last one, this one has a square here. So I know that the square root of 64 is 8. So 8x, the square root of 121, is 11. So it's 8x plus 11, 8x minus 11. All right. We have some of these. You may encounter them where you have something like 9 minus x squared. If that's the case, then it's just going to be 9 minus x and 9 plus x. You may see some of those in your assignment. All right, hope you enjoy the notes. Have a great, fantastic day, and we will see you sometime next week.